Okay, so this is chapter 23, problem 43, and we'll also do 44. So these both involve finding the electric field, knowing the voltage. So in problem 43, 23.43, we have that the voltage as a function of x, y, and z in three-dimensional space is equal to axy minus bx squared plus cy. And a, b, and c are positive constants. Now remember, voltage is a scalar quantity. That's why we don't have I, J, or K. It's not a vector quantity, but it's a scalar quantity. So all you do is you pick it, put in the y, x, y, and z coordinates, and you, if you knew what A, B, and C were, you calculate the voltage at a certain location in space. It says calculate the x, y, and z components of the electric field. At which points is the electric field equal to 0? So if we go to the book and look for the appropriate equation, we'll see that if you go to page 775, which is a summary of the chapter, you'll see that the components of the electric field are negative the partial derivative of the voltage with respect to x. So the electric field in the x direction is negative the partial derivative of the voltage with respect to x. The electric field in the y direction is negative the partial derivative of the voltage with respect to y. And the z component of the electric field is the partial derivative of v with respect to z. And the electric field vector, so electric field is a vector, so you get a vector by taking partial derivatives of the scalar function. So there'll be e sub x times I plus e sub y times j plus e sub z times k, and of course a, I, j, and k are the unit vectors in the coordinate directions. So how do you do partial derivatives? Well, what you do is you assume that the variable that's not involved with the partial derivative, you treat those as constants. So the first one, e sub x, is going to be negative. And so then we take the partial derivative. So y is a constant. So all we're doing is taking the derivative with respect to x. So we get ay here. The derivative of x with respect to x is 1. The derivative of x with respect to x squared, the derivative of x squared with respect to x is 2x, so we get negative 2bx. So there's the 2x part. And the derivative of cy with respect to x is 0, because when we take the derivative with respect to x, y is treated as a constant, so this c times y is a constant. The derivative of a constant is 0. Now e sub y, do the same thing. It'll have negative. Now we take the derivative with respect to y. Well, the first and the third term have y's in them, but the second term doesn't. So this one, instead of being ay, when we take the derivative with respect to y, we get the derivative of y with respect to y is 1. So we'll get ax. The second term is a constant when taking the derivative with respect to y. So that's going to be 0, and then the final one is going to be c. Derivative of y with respect to y is 1. And the electric field in the z direction is going to be 0, because none of these three terms involve z, so they're all considered to be treated as constants. So that gives us the electric field is going to be equal to, so I'm going to distribute that, so it'll become 2bx minus a sub y times the unit vector I plus, again, we'll just go ahead and distribute it to both terms. So negative a sub x minus c times j, and there is no k term, or there's k term is 0. So that's the electric field vector. Now the second part of the question asks is what are the values of x and y where the electric field is 0. The z direction doesn't make any difference. So all we have to do is set these components equal to 0. I'm going to use the one down here. So we'll have 0 is equal to 2bx minus a. Wait a second. What is this? Yeah, a sub y. A times y. So it's 2 times b times x minus a times y. And 0 is equal to minus a times x minus c. Okay, so we have two equations, two unknowns, but we can solve the second equation for x. We'll get x is equal to negative c divided by a. Because if we move this to the other side, it becomes positive c, and if we divide by negative a, we get that. So that's x. Then what you can do is you can plug this x value into the first equation. So you get 2b times x, which is negative c divided by a, minus a times y. So what do we have here? We're going to have 2bc over a is equal to negative a times y. What I've done is move that to the other side, so it becomes positive, and I have 2bc divided by a. And then finally, you're going to divide by a, negative a. So you get y is equal to negative 2bc divided by a squared. So that is the answer. Those are the answers, whatever the constants are. We don't, this is in terms of the unknown constants, but if we had specified the constants, we could calculate the values of x and y where the electric field, all the components of the electric field are 0. And this problem does have the answer in the back of the book, and that's the correct answer. Okay. So that is problem 43. I think I'll do a separate video for 44.